Alrighty, hi everyone. How's everyone doing today?
Good.
Oh, sweet. All right, so I am Michelle Noorali. We're going to talk today about developer-friendly APIs for Service Mesh with Service Mesh interface. Don't worry, I'm not going to just sit here and talk to you about a specification. There's demos, and we'll look at the implementation. So a little more about me. I'm a software engineer at Microsoft Azure. One of the biggest projects I've worked on is Helm. I've been working on that since 2015. I've also worked on several other open source projects in the space, and most recently I've been working on maintaining the Go SDK for SMI and the Istio adapter. We'll talk a little bit about that later today. I'm pretty involved in the CNCF. I serve as the developer representative on the governing board and on the technical oversight committee. I was also KubeCon 2017 co-chair, and anyone who knows me knows that I'm very passionate about donuts. Okay, so I'm going to talk to you a little bit today about pushing to production. It can be pretty scary. It can be scary for the developer writing the application code. It can be scary for the person who's responsible for making sure the application is up and running and those credit card transactions are going through. It's also pretty scary for the CEO that told all the investors that this was the next Uber for X. So there's a lot of pressure, and it's justified, right? Who hasn't actually broken production before? Raise your hand if you have broken production. Okay, cool, all of us, great, awesome, sounds good. Yeah, I remember my first time breaking production. It was a beautiful day, it was sunny. It was an if-else statement. I just switched the logic for no reason. And I pushed, and the next thing you know, I was sitting there in my very first post-mortem session. But I think that's why we're all here this week, right? We want to stop breaking production, and building and running distributed systems is super hard. And we got a little bit of the way there, well, a lot of the way there, to be honest. Docker was amazing. So we got to, finally isolate our applications in these consistent environments in our Docker containers. We now have Kubernetes. We can orchestrate those containers. That's awesome. And the Cloud Native Computing Foundation became this home for all of the tools and technologies you might possibly need to build and run and democratize distributed applications. And I remember that it was KubeCon North America in Austin in 2017. It was December, I think. Oh yeah, the date's there. It was December. It was cold and rainy, and those few days were when Service Mesh just completely exploded. And so we saw this explosion of the Service Mesh. And it was a really good time for it. We had the packaging done, we had the orchestration system done, we had really good tools for monitoring and logging, and this next evolution for figuring out how to make sure your service-to-service communication is reliable, that just seems like it would flow. And also, the analysts were really hungry for the next big thing. Everybody was blogging about this stuff. It was excellent. And Linkerd, I believe, was the first service mesh to be donated to the CNCF, but more meshes came to the party. And everyone was super excited, especially our customers, right? Like, customers would come to us and be like, we really want to use this service mesh. And with any good thing, there are costs associated to it. So the cost of, I'm sure we've talked about this earlier, but there are infrastructure costs to running the service mesh. There's the cost of figuring out which mesh to use. You need to dedicate time and experience. You might be fixing bugs as an early adopter, so you might want to or have to upstream those contributions. And we're all in new and uncharted territory in terms of tooling and UX. And so that left our customers with and end users that we were talking to with this particular question. And it was to mesh or not to mesh. But we believe that is not actually the question, right? We we were in this like search of figuring out what it is, if it's not just the generic like service mesh super hype term, what is the thing that people are looking for, that end users are looking for? And we talked to a lot of customers, conducted a lot of interviews, and it really came back down to like 3 particular things. One was they want to be able to execute certain deployment strategies. So Canary is like the first thing that people talk about. They wanted to be able to control which services communicate with each other and how. And they wanted insight into what is happening in their microservices environment. And this may not be new information because I'm sure a lot of you already use a service mesh or are familiar with it. So raise your hand if you're running a service mesh in production. Oh, actually, that's not everybody. That's like 10%. Who has played with service meshes before today? Oh, awesome, great. Okay, this is a great audience. All right. So we wanted to do something in this space, and we wanted to figure out how to meet our customers' needs, but also lower the barrier to entry and risk of using a service mesh. And we did this in collaboration with the service mesh community, so folks from Linkerd, from Meshery, from Solo, and the list goes on. I've had the pleasure of working with a lot of really good people in the community for the last few months. So anyways, we also wanted to create a consistent experience for end users and tooling. So if you want to carry out a particular deployment strategy, it's different in every mesh. And we also wanted to bring different parties together to create an ecosystem. If you look at the things that are in common of the projects that are in the CNCF, you'll find that CNCF projects are generally interoperable and flexible and extensible. And so this is the kind of feel that we wanted to bring to the service mesh community. Okay, so going into service mesh interface, SMI. This is a standard. It's a document, it's a spec. It documents and standardizes key functionalities that service meshes provide, key common functionalities. And the 3 areas map to the 3 areas of concern that I mentioned previously. Insights and observability, access control, and policies and traffic splitting. So the spec is in the form of Kubernetes custom resource definitions. So each part of the spec is a CRD. This, for example, is the traffic split spec. And you'll see there's a root service, and there's some backends, and there's this thing called wait. And wait is correlated to how much traffic you want to send to a particular service. So you may want to start sending like 10% of your traffic to a service, and then carry forward and progress. And you, in reality, are probably doing this with a tool or want to do this with a tool, but you can do this by hand if you want with the SMI traffic split resources. And we'll go into a little bit about that too. So we have a few different CRDs. I'm not going to go too into detail in each of them because I want to show you like how it works. But there is an SMI SDK. So in this spec, we define these CRDs, this specification for how you define certain behaviors and certain things you can do with the mesh. But in the SDK, we have these CRDs implemented, these APIs implemented so that you can just import them into your project and use them yourself. For example, if you wanted to build an operator that watches these CRDs and then does something to your data plane. This is the traffic policy example. So I will kind of give you a high-level overview of what this is actually saying. So if you start from the bottom, it says in the traffic target section, basically we have an API service, and we only want to allow Prometheus to be able to hit the metrics URL. In essence, that's what that's saying. This is the metrics one. And I just want to show you a demo of how the traffic split works. Y'all ever do that thing where you get up on stage and then forget how to type? Because like I forget all my Vim shortcuts and everything all the time. Okay. So we are in, I aliased kubectl to K because I don't spell kubectl correctly ever. So I'm on a cluster that's running Istio. We're gonna see what's running here. I'm just gonna delete this V2 version, and we'll go into that a little later. But basically, I have a Node app, and all it does is it calls a greeting service, and then the greeting service is a Go app, and all it does is send back a greeting and a color, and then we use that in the Node apps like view. Okay, so we are going to go ahead and see what that looks like. I could have shown y'all like a lot of different services like running together. There's like lots of demos like that. But for this demo, I just have 2 services here because I wanted to show you everything in a very simple context. And then you can also use this code base to build more complex demos or examples. I have like 5 or 6 different services that you can like use. Okay, so we're going to use kubectl port forward to get this like localhost URL. We exposed the Node app on port 8081, and that's just because I'm really lazy about load balancers, about provisioning load balancers. Okay, so super simple. It just says good morning, and the color that it passed back was like an orange one. Now I'm going to go to the greeting service and, oh, actually, hold on. I'm going to do this in a different window so it's a little bit easier for me. Okay, so I have some manifests. And these are traffic split manifests. So I have version 1 of my greeting service running. But what I want to do is control and manage traffic shifting. So I'm going to show you what my traffic split looks like. And basically, it just says that I'm going to give 100% of my all the traffic to version 1 and nothing to V2 to start with. And so I'm going to go back to this greeting service, and I also have some manifests here. And so V2 greeting service just has like a different message and color that it passes back. I'm going to go ahead and deploy this traffic split object to make sure my traffic is controlled when I do my next deployment. Okay, cool. So now we have this greeting service. And if we go back, and also Istio injection is enabled, so it's going to take a second to get this running. Okay, cool. All right. So if I go back to my app, I should only see good morning. We're still good. Now we're going to do the fun part, which is shift some traffic. So this one says that I want 90% of my traffic to go to V1, and I want 10 of it to go to V2, so I can start playing with that. I just recently updated the version of the CRDs, so I'm going to go ahead and update that here. Okay, cool. So now we should be seeing like 1 every 10 requests come back as good night. That's been 10. Hold on. I'm just going to follow these logs too. Is it tail? Oh, shoot. Thank you. All right. I didn't actually test that traffic split, so I'm just going to do the 50% one to see how that goes. All right. This is what happens when you don't actually, when you make changes to your service like 5 minutes before the talk. So, okay. So, all right. So just to recap and bring us back and bring me back. So I have 2 versions of the greeting service running, V1 and V2. I have my Node app up and running. And I just applied this traffic split object, which should start shifting traffic for us. And so we're going to go back to our browser. And OK, cool. So now it's like half the time it works, which is good. We want 50% of the traffic to go to one and 50% of the traffic to go to the other. OK, so that's all well and good. Let me make sure I have enough time. All right. Now I'm going to get like more, I'm going to switch clusters. So so I have Linkerd running on another cluster. And I also have some stuff running here. I have V2 and V1 running here. So I did that just to save time. We're going to open up. So I learned about this actually yesterday. Linkerd has a dashboard, which is cool, but I also switched laptops right before the talk, and so I didn't have the Linkerd binary, so I did all of the right things. Okay, so with Linkerd, they have this. They just added this traffic split section to the dashboard, which I think is pretty cool. So you can see like the latest traffic split, and you can make requests and kind of see metrics around that, which is pretty sweet. But it's the same. Like actual CRD. So let's just switch it up a little bit to prove that it's all running correctly. Okay, so I still need to port forward, but I can't port forward on the same thing because this is a different pod. And we're running on port 8081. Okay, so we still have our app. Okay, and this is saying that, or we're gonna go back to our manifest and apply a CRD, apply a traffic split resource. Let's see. And I want everything to go to version 1 because something happened. There are tools that will detect, and analyze like metrics around success rates and then roll back for you. But I'm just doing this manually just to kind of get, help us understand everything. Okay, so I want 100% of my traffic to go to V1, and I see that it's correct. Linkerd is supporting the old version of traffic split because I just changed it recently. So, and does anybody remember which oh yeah, good. Okay, cool. So now we should go back, and we're seeing that 100% of the traffic is going back to the version 1 of the greeting service. And you can see information about that in the actual dashboard. So this is just to show you that you can have the same experience on different clusters running different service meshes. I stole this diagram from marketing, and it basically shows you kind of where SMI fits in the ecosystem. So you have a bunch of meshes, SMI kind of sits in the middle, and you can build apps, tooling, or ecosystem projects on top of it. And this is important because the ecosystem around service meshes are evolving. There's some really, really cool things that are coming out. And a lot of them use SMI already. And even newer meshes that are coming out are starting to use SMI as like a first-class thing. And so I think this is the thing that's most exciting. It's not necessarily that you as an end user or a developer are going to try to do your own canary deployments. Like, that's not really the goal here. The goal here is to build developer-friendly APIs in which we can build tooling on top of SMI and service meshes and create this consistent experience and really grow what kind of workflows we can have. So. Flagger is amazing. It's this Kubernetes operator that helps you do canaries. It uses Prometheus to check metrics and do rollbacks. You can even hook in load testing and other things in that. So there is a Flagger demo in the Istio adapter project. And I didn't explain that yet. So Linkerd has like first-class support for SMI. We created Istio adapter, which is basically an operator. It just watches the CRDs, the traffic split, and all the SMI CRDs, and then it informs Istio about what changes it needs to make. So. But anyways, there's some really cool stuff coming out, or has come out. Flagger, service mesh visualization tools like Kiali, and benchmarking tools like Meshery. So just things to kind of give you an idea of, like, if you're trying to build tooling, we'd really love to talk to you about how you can use SMI and leverage those APIs. I mentioned the Istio adapter. It has really good example demos, so check this repo out if you want to play with SMI some more. And if you want to get involved, we have a pretty active community. We have a Slack channel. It's all on the SMI-spec website, and we have Zoom meetings every other week. So if you're even thinking about using SMI, please hop in, tell us where you're from. We'd love to hear from you. And this slide was originally called Synergy, but I took that off. But basically, just to reiterate, SMI is something that allows people some flexibility and takes away a little bit of the edge about getting locked into a particular service mesh. It helps people with interoperability. You can build tooling against SMI and know that your experience will be consistent and not have to worry about whatever service mesh is implemented under the hood. And it doesn't hinder service mesh providers from adding cutting-edge features to their meshes while still giving that kind of consistency to the end user. Thank you. Please let me know if you have any questions. I'll be at the Azure booth tomorrow and Wednesday, and the Helm booth on Thursday. That's it. I gotta run. I have a meeting. Thank you.